Okay, I think it's okay. Okay, now it's okay. It's record, right? So let's continue. Okay, we are still in chapter 2. Um, hopefully you stay interested, or so far I hope that you can follow my lecture, because we are um, slowly entering the fundamental of image processing. Um, Previous lecture, it is more on application, more to the general knowledge, but now we are starting to move in to the details of image processing, which is very important in computer vision, um, especially once, because if you have knowledge on the basic or theory, um, it is easy for you for next task, or for next action. For example, if you want to develop a system, um, if you have a basic, then it is useful for you in developing a machine vision system. Okay, so I think we stopped somewhere here last lecture. So let's me continue to finish on this chapter. This chapter 2. Okay. So this is I'm talking about pixel. This is about pixel. Um, when we have image, this is the image. Um, Image, we return a size, row by column size. Size give the resolution of the image. Resolution is the row multiplied by the column, then you get the resolution. So each resolution in the image, we call it pixel. So if we zoom and to see the the details of the pixel, we can represent the pixel in a form of matrix like this, So this is the zooming lah, 3 by 3. 3 by 3. As I told you last time, um, the resolution of image, um, it is heavy rain here. I'm sorry, need to close all the doors. Okay, so let's continue. um, I think everyone is familiar with the resolution. I mean, because nowadays um, people are looking at a good camera. when you buy a handphone, one of the main criteria for you to choose what type of handphone, you will look at the specification of resolution, right? Some camera, they have up to like 100, 100 megapixels, front and back camera. They have more than one sensor, the camera, because to get a good um, image, uh, because people nowadays want to share their life to the people around the world. So if you don't have a good camera, so your image is bad, nah. So you don't want to share the bad image to the other people, right? You want people always look at you smart, beautiful, handsome, because you want to attract people to come to you. Uh, so that's why handphone, um, any type or any brand of handphones, the manufacturer are trying to give the best um, camera, specification. But some of us don't care about the specification. They care about the brand. Uh, if you want to buy iPhone, you don't compare the specification. You just look at the brand. Although people say that, oh, don't go for iPhone because of the camera is lower, something like that. No, no, no. You still want to go for iPhone because of the brand. That's the another um, segment of buyer. All right. So that's the um, the situation. I mean, your understanding about a camera. Sometimes you don't care about the resolution of your handphone's camera, because when you buy a new phone, of course there must be a high resolution. Even maybe because of all camera have the high resolution, so you don't even bother about the megapixel anymore. You don't It is not excite you, the resolution 100 megapixel. Okay, but in a machine vision system, the higher the resolution, um, the higher the processor needed. In machine vision, we don't use um, up to 100 megapixels, uh, because high resolution require high processor processing time, more processing time, so on. Yeah, because the machine vision, we are process the image, but like if you use handphone, you are just capture the image then just display. It's nothing to do with the processing. Even in machine vision, if you use 8 megapixel or maybe 4 megapixels camera, or 12 megapixel is more than enough. If you go more above the 12, it's already consider um, higher, because because uh, because we need to process the image. The higher the resolution, um, more difficult. You know, the frame per second, you have to consider a lot of things. So that's the situation, you know. Okay. So go back to here, pixel here. Uh, when you look at at one image, always because we are learn the image processing, always remember that uh, we are process image processing at the pixel level. We call it pixel level. Okay. So this is uh, for this example, figure 2.21 here. This is a 3 by 3 size of image. If you display this one, even you can't see in your image because very small, 3.3. If if you use uh, if you use 8 megapixel, for example, then if you zoom up to 3.3, you don't even see what is the object in the image, right? But to give you very simple example about the pixel, then we have to zoom in up to 3 by 3, 4 by 4 lah, easy for you to understand. Okay, right. So this is the when we look at this matrix ni, this is row, this is column, 3 row, 3 column. So the value inside here, we call it pixel value. Okay, maybe we have some. Okay, go back to here. So if you take this as a let me, I heard something. Oh, what is this thing? Wait, oh, someone want to join. Maybe it is automatic. Okay, never mind. Okay, let's go back to here. So this is the, if we choose one reference at the middle of the matrix here, 3 by 3. So there are definitions of neighbors of a pixel. Okay, this is neighbor of pixel, neighbor of pixel, neighbor of pixel, neighbor of pixel. This is all important in image processing, you know. Because in image processing, each pixel uh, contribute something, you know. Contribute something. So that's the idea, right? So this is the definition just now. I think later lah. We have 4 neighbors. Okay, so you can refer to the figure 2.21. What is the meaning of 4 neighbors? 8 neighbors. Okay, the neighbors. And the other term on the neighbor of pixel, it is the connectivity. Connectivity is useful in image processing to represent region boundaries. or edge. Connectivity defines the adjacency between pixels. Connection between pixels is determined when the neighboring pixels have the same value in a binary black and white image, or values are close to each other for a gray level image. So this is, we call it connectivity. Connectivity, so this is the definition about connectivity lah. But if I want to go for simple and detailed example of the connectivity, it's like this. I will give you um, um, very very general example about the connectivity. For example, we have image like this, 2 by 2, for example. If you have a pixel value here 0, and you have the neighbor is 0, so here from this one to this one, it has a connectivity. Okay, connectivity. If you have this 200 here to 01, it also have a connectivity lah, although it is not same, but the value is just very small different, then you still can consider it has a connectivity. But from here to here, there is no connectivity. So that is the meaning of the connectivity, connection. So this connectivity represent boundaries or edge, right? Boundary or edge. Okay. If you don't understand, you can ask me through text, through chat later. Okay. It is very, very important to understand the basic. This is very basic, and the way I explain to you also very step by step. Hopefully you can understand. I give you another example about this one to explain this one, region and age. Okay, for example, I have this image. For example, uh, let's have color black. Macam tu. Hitam. Ni let's say this is all black lah, walaupun dia tak nampak cantik. Okay, macam tu. So, ni bagi cantik sikit. Okay, like this. Ini dia punya frame lah. This is the frame macam tu. Buruk. Okay, never mind. Here you see white. Here you see white. Here you see black. Pixel value for white is pixel value for white is 255. Pixel value for black is 0. Kan? Dia merah. Okay, here, inside here, somewhere here, there is a connectivity. Yang putih ni pun sama. Dalam ni, they also have a connectivity. So to explain this definition ni, represent region boundaries or edge. Where you see edge? Here you see edge, right? Here is the edge ni dekat sini. So edge ni means that there is no connectivity. Why there is no connectivity? Because white is 255. Black is 0. So tak adalah connectivity. There is no connectivity. That's why connectivity ni, when there is no connectivity, you can see edge. When there is connectivity, macam ni kan, here, dalam ni, in this X ni, in this area, so this is all 0. So no connectivity, no boundaries, no. So that's the idea. Okay, that's the idea. Okay. And this is another measurement where it is useful to do analysis of image. Base, pixel base. This is one of the measurement where distance, where we call it distance measure, Euclidean distance. Okay, so ni sama juga. Tengok. This is the Euclidean distance. Euclidean distance. There is a function, Euclidean distance in image processing. So you just go through Euclidean distance ni. You have one point pixel value. This is another point pixel value. Then we can measure the distance. So maybe you don't see what is the application of this measurement, but later uh, uh, with some application or certain analysis when you make to your image, you may want to use this Euclidean distance in your image analysis. But I didn't give you example of this Euclidean distance. Okay, you can search by yourself. So this is the exercise. You are hired to design a front end of an image system for studying a boundary shapes of cell, bacteria, virus, and protein. So this is medical. The front end consists, in this case, of the illumination sources and corresponding image camera. The diameters of circle required to enclose individual specimen in each of these categories are 51, 0.1, and 0.01 micrometer, respectively. Can you solve the image aspect of this problem with a single sensor and camera? Illumination wavelength bands of the type camera. If your answer is no, so I think just ignore this exercise now. This is very technical. Okay. So this is again still about a pixel. All right. If you don't understand on previous slide, I will explain this image representation, and I hope that you can understand what is the pixel, what is the resolution, how to interpret an image based on pixel. It is very, very important, all right, to understand image processing. Okay, before we discuss image acquisition, recall that a digital image is M row and N columns of pixels, each storing a value. Okay, It means that, as I told you just now, image, it has a row and column, which is represent pixel. This is pixel kan? One pixel. So inside this pixel, it has a value. So pixel values are most often gray levels in the range of 0 to 55. We use this range. Uh, 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 there is another definition of pixel value, not only between this range, but um, I I will use this range. I will teach you this range, and most of the application of image processing, uh, it is used this range of pixel value, 0 black to 55 white. All right. So the number or the value in between 0 to 255. So the color is black to white. Eh? So this is the pixel value. Okay. So this is also try. I hope you can try to understand the another definition of, I mean, um, representation, image representation. Image representation in a form of matrix, and we can represent also in a form of matrix like this, the based on the function fxy. F00 is pixel value at row 0, macam tu, right? F01 until n minus 1. So this is another representation in a form of function xy, fxy. xy xy ni is refer to x axis, y axis. But if you put in column, uh, it is presented in row and column. Row, if you look at the axis, row is y, column is x. So a little bit confused here lah. But later on, when you always use this term or notation, you will get familiar with this one. A little bit confusing here. Row, column, x, y. Okay, so this one also, this is the, I just skip this one. You can go back later and try to read by yourself and try to understand those. Saturation and noise. Image exhibiting saturation and noise. Saturation is the highest value beyond which all intensity levels are clipped. Noise in this case appears as a grainy texture pattern. Noise, especially in the darker regions of an image. Okay. A noise is something that we don't want. It will disturb the image lah. Something like that. To show you more practical, more practical application. I'm not sure I think you can see this one. Oh, this is not live anymore. I can show you the system, the vision inspection biscuitware. This is, we call it biscuitware. bukannya biscuit Hapseng tu. This is biscuit ware. Biscuit ware ni, biscuit ware is a term that used in um, ceramic industry. This is the product before they go to glaze, spray glaze color. So we call it biscuit. This is a term in the ceramic industry lah. Biscuit ware. Biscuit, they call it biscuit. Biskut tu lah, biskut yang kita makan tu kan. Okay. So this is all noise lah. Noise ni, noise. Noise hitam ni, shadow. I don't want this shadow. This noise affect the defect that we want to see, you know. So this is the example of noise. Of course, background is also we don't want, right? But background ni, it is easy to remove because color is a very contrast with the object. So we can easily do the color segmentation. But this shadow ni, very difficult, because if you are trying to remove the shadow by the method or technique of image enhancement, the result you will get a good output. There is no shadow, but the algorithm might remove the defect as well, because sometimes the defect, the characteristic or the features of the defect is similar to the shadow here. So that's the challenging. So we have to use good lighting in order to capture a good image without shadow. So that's the idea. Okay. Since I already opened this MATLAB ni, I would like also to let me give you very good demonstration, okay, about the pixel. OBW. Oh, not this one. Okay, sorry. Okay, let's have one image. I'm not sure you can see or not. Okay. So this is image, right? This is an image. So where is the pixel? Okay, let me show to you. I'm not sure whether I hope you can see lah. So this is what is this? This one. This is a pixel value. 2160 multiplied by 4096 resolution. 3 means that color lah, RGB, red, green, blue. Red, green, and blue. Yeah. Okay. All right. So how the pixel looks like? Let me show you. Okay. Go to here. Image viewer. File import from workspace. Okay. All right. So this is image just now with a resolution 8 megapixel. If you multiply, you will get around 8 megapixel. Okay. So if we go to the detail pixel value, nampak apa pun tadi kan. Oh, so this is the maybe how much the size? 30, 40 something. Okay, let's see the information. So value. Here. Okay. So this small crop image. So this is the pixel value R, G and B. R, G and B macam tu kan. 201, 206 sama je because it's very small. Very small. If you macam tu lah. So that's the idea. Yang small. It's small. So, gerak lagi sini. Go to pixel value ni. So this is the pixel value. Okay. So let's close. Let's go back to the hilang. Never mind. We close first. Go to the okay. So that's what we are talking about pixel just now. 3 by 3. If you go to the 3 by 3 in the image, you won't get any information because we are visualize the image. So with 3 by 3, what visualization we can get? What information? Of course, we just get information about the pixel value. But here with this size, then you get lah the information. Age, semua kan. Object, color and everything. But if you go to very small, then you cannot get the information. That's the idea. But you have to understand, image processing is about pixel value. It's about value. So you just imagine how many values you have. 8 megapixels. Mega is a power of 6. So that's why we need a software to analyze. We don't analyze by ourselves. We use a software. But in order to use the software, you have to understand. You have to have a knowledge. You have to have a theory in your mind. So in order to learn, in order to acquire the knowledge, that's why I give you very small example, 3 by 3 tadi kan. 4 by 4. I don't give you big example. You don't get it. You don't see it. So that's the idea. So let's go back to the slide. So noise. I will nak cerita pasal noise tadi. So this is the noise lah. Shadow ni kan. We don't want the shadow ni. Although you see this is shadow lah. Simple je. But in analysis pixel value, this shadow will affect the region or the pixel that we want. Kan? For example, black dot. Black dot is black. Sama lah. Shadow is also black. So which one is black? Which one is black dot and which one is the shadow? That's the problem. Okay, so this is the noise. Noise is something that we don't want. So far so good. We stop at 3 lah. We start at 3. The rest you can refer to the slide, and also you can go to the kalam. I already restore all the materials from the previous semester, but I will rearrange it. You can see all the material of the previous semester, but I will arrange it accordingly lah, based on the lecture. For example, chapter 2, then I will arrange. But if you want to jump to get the material of chapter 3, chapter 4, then you can just go to the previous materials. Okay. So let's see this slide. What is the digital image? Common of image format is 1 sample per point, 3 sample per point. So in this, that is disturbance, noise. 1 sample per point, 3 sample per point. 4 sample per point. We don't learn this 4 sample per point. I also no idea this 4 sample, but normally we use this. 3 sample per point means that 1 point, 1 pixel value, 1 pixel value. Tadi kan matrix tadi tu, it has 3. The apa? MATLAB that I just showed to you just now, we have 3 kan, RGB. So this is kalau 1 sample per point ni black and white or grayscale. So this is 1 sample per point. This is RGB, 3 sample per point. Very straightforward and very simple.
Cerita Pem Ramli tu guna 1 sample per point lah, Prof.
Grayscale. Grayscale. Kalau 1 sample per point ni, you don't see the variation of black to white, kan? Although it is apa tu? You see black color, black and white color. It has a range. Black tu range of black kan, darker ke bright macam tu lah. But 1 sample per point, correct lah, 1 sample per point of grayscale, not the 1 sample per point of black and white. Black and white ni 0 and 1. Grayscale is 0 to 5. RGB at 1 point, you have 3 value. The value is 0 to 255. Okay. Piramli tadi tu boleh buat color lah sebenarnya. Ini apa ni? What is this?
Another factor influencing the size of objects we can see is the wavelength of light. So remember that the wavelength of light is related to the frequency through the speed of light using this equation here. So through the principles of optics, we know that we have to use a wavelength equal to the size of the object or smaller if we want to see the object. So with standard light microscope methods, we could see an object, let's say, down to the size of a bacteria, about 1 micrometer or smaller. But to go, let's say, down to a virus or lower, we need a smaller wavelength, such as that you could get with an electron microscope. So the visible spectrum is actually a very small portion of the entire electromagnetic spectrum here.
Okay, so I think this one is just you can watch later, because this is the about the image acquisition. So this is the 3 sample per point. If you just go to the red component, there is no red lah. This is gray scale. You see this gray color kan? 0 to black to white. G also same. B also same. Okay. But if you combine all these three, all these three, you get color lah. Macam ni kan. Dia senyum macam ni. Okay. I think my last sharing I would like to show to you with regard to this slide. I will go to the MATLAB. Okay. Go to here. Okay, here. Load image. Workspace. So this is the example. If I choose RGB, this is the color space, a lot of color space. We are going to learn this all color space later. But normally in image processing for machine vision, we use RGB lah, RGB. But I don't know later, maybe for certain application, maybe you will experience using other color space. Okay, so this is the histogram. We call it histogram, RGB. This is the pixel value of R, pixel value of G, pixel value of B for this image, for this size of images. This size. Histogram ni maksudnya how many pixel value are in this image kan? RGB. Yeah? For this point, for example, for certain point. Kalau nak, this is a color threshold. Macam ni lah. Okay, I will show to this one. RGB, just to explain to you RGB. So if I click one point here, so this is the value 172, 198, 63. R, G, and B. R, G, and B. Then you see the color. Kan? Because it is combined red, green, and blue. You see the color. Kan? Here pula 200, 205, 199. Right? So that's the idea of RGB. 200 is gray scale value to the gray scale value 0 to 255 kan. Green also 205, 199 for B. So that's the idea of RGB. So go back to here. Okay. So this is RGB. If you don't want the background, for example, then you remove the B. Kan cantik tu. Those who are doing a final year project and using MATLAB have a lot of apps where you can use, to process your image. You don't have to type a coding, and then you just present end result lah to your supervisor. I believe your supervisor will impress with you because uh, because the supervisor also don't know how to use this MATLAB. Mm. But you can explore MATLAB and a lot of helpful apps you can use. Okay, you don't have to worry about to write a coding. You just use the apps, then these apps automatically write a coding for you. Export the function, and you can use it to the main program. Very easy, right? Very easy. Then very nice segmentation we get. You know? So go back to here. But if you want to remove the higher blue here, it's not good lah. They remove yang your object itu. Okay, so that's the MATLAB. Okay, I think that's all from the slide. So the rest you can get the PowerPoint, and you can also go to the column and watch the video of the previous semester. Okay, so there is an assignment uploaded to the column for the assignment 1. The group assignment, there are 10 groups if not mistaken, but I'm not sure whether the list of the name is up to date. It is up to date because I I just download the list of the name today, but I'm not sure, maybe some of you already drop or what, delete or remove this subject from the registration. So whatever member list you get, just accept, try to communicate to each other. I don't want to listen the any reasons about the team member not cooperate, because I have a few cases last semester. If you don't cooperate, then I consider that uh, you fail to submit the assignment. I don't want you to submit individual, because this is group. Later when you work in industry, you cannot work alone. There is a trap interview question asking whether you are prefer to work in a team or you prefer to work alone. Some of you might want to work alone because you think you are good, right? You can do everything. You can answer all the question. But it is not good in a company or industry. You cannot work alone. The company cannot grow. If you answer, oh yeah, I prefer to work alone, definitely the company will not hire you. So learn to work in a team, learn to communicate. If you have a problem to social, to make a social, to make a friend, so this is a time in the university you have to learn it, because in real world you cannot work alone. You have to rely to other people or to other person. Okay, so everything is in the column, all information in the column. Then you can see the question. I give you only 1 week. I want involvement all the member. Okay, don't become a sleeping partner. I want you to appoint one head, and then you delegate the work. All right. Then upload your answer or report in Kalam within 1 week. If you have any question, then you can text me. But uh, but I think it is very easy then and very straightforward. Uh, um, when you ask, you actually already got the answer. Okay. So I think that's all for today. Hope to see you again next week. And hopefully we can I can move to the chapter 3. I open if there is any question.
Prof.
Hmm.
Assalamualaikum, Prof. For the assignment report, in what format ya?
Uh, um, uh, in PDF format. Any format you like, but save in PDF.
Okay, thank you.
All right, thank you, Ibrahim Adam. All right, if there is
Prof,
yeah.
untuk kelas ni will be straight online sampai habis
Oh, that's very good question. You are in a campus, huh? You are in campus. You want to have a physical class? I'm not sure. I'm not sure the policy. Because I don't know whether maybe I'm not follow the group, the management or the lecturer groups. But as far as I know, a lecturer have an option to continue with the online class or physical. I'm not sure. Or you want me to do the physical class?
Some of us ada yang tak balik.
I prefer online, sir.
Let me discuss with faculty and see, because I heard that Dean has said verbally encourage lecturer to have a physical class. But I'm not sure the direction of the faculty. But it's very good question, a very good suggestion. We will see those who are in the campus. Maybe we can have a physical class, but at the same time synchronous with the online class. So I can meet you, then you can see me face to face with this straight SOP lah. Perhaps everything is okay lah. Let me discuss with the top management and faculty, and also discuss with colleague and see how this class will be conduct next. Yeah, Ibrahim.
For the student that are currently residing at Gambang, will continue to be, I'm third year. So I'm at Gambang.
How many of you in Pekan? Some or all of you in Gambang, or some of you in Pekan?
Some of us in Pekan.
Yeah.
Okay.
I think most of the students who got back are at Pekan right now.
Okay.
Only
Good.
some.
All right. So if you are in Gambang, it's better to stay in Gambang than join the online lah. Unless you want to come to Pekan, because sometimes you want to go out as well, right? To drive car ke. But if you want to stay in Gambang, just join the online. But whatever the decision, I will inform you later. I need to refer to the top management and see the direction. But good to have a physical class, right? At least one or two. You also want to see me, all right? Although now I'm very busy and prefer to work from home because I have my workstation of the project, the pinggan project ni. If I go to the campus, then I cannot do this project lah. But if I stay at my house, I can do the project as well. But never mind, I will inform you. I will get back to you soon whatever decision whether to go for the online class or not, physical class, to have a physical class, I will refer to the top management first. Okay, is that okay? All right, if there is no more question, thank you very
Prof,
much.
So
Yeah, please.
go ahead, Dylan.
Prof, when can we get the list of names for the assignment one?
Inside Kalam already.
Yeah, already upload to the Kalam, so you can
Okay.
refer to the Kalam.
Okay, thank you.
Yeah, any more? Amba?
Sir,
Yes.
may I know that the report should be in a single line format or IEEE format, sir? And also
No,
the
no, no.
summary,
Just
the
that is,
submission
I
is
don't care what kind of format. Just I want to see only the answer.
okay, sir. And then one more thing is assignment is submit should be in 1 week, right? So by next Thursday.
Yes. By next Thursday, 12 o'clock.
But next Thursday is Deepavali, sir. That's why.
Yeah, then before lah.
Okay, yeah.
Right. Okay, Amba Menanti. All right.
Thank you, sir.
Thank you very much. If you have any more question, you can text me. All right. Thank you. See you again. Bye-bye.
Thank you,
Prof.
Doctor.
Thank you, sir.
Thank you, sir. Bye-bye.
Thank you, Prof. Have a nice
Thank you,
day.
Prof.